All right, so welcome back. So what is an ionic compound? This you can get, because it's your study guide, you can get this directly from you can get that from here, from the formula of ionic compound. You've got ionic compound. It also should maybe even be in your toolbox, in your notebook. So formula of an ionic compound, it will say it is an atom or group of atoms that have a positive or negative charge, and that's really what it is. So a group or of atoms, or an atom or a group of atoms that have a positive and negative charge. Fortunately, you wouldn't have an ionic compound that had two positives, so the wording on that, the positive and negative, you wouldn't have just two positive charges, because then that wouldn't be an ionic compound. All right, so how do you know when to use Roman numerals in an ionic name? And why do you use them? So there is many ways that you could say this. I'm going to explain this to you as best as I can. So on the key that I gave to you, or that you'll have actually next class, is when you're going to have, when a cation, remember that metal, has more than one version. So the transition metals often, so those are the ones between, so you group 1, group 2, then you've got those whole in between. So transition metals usually have what we'll call a version, usually have more than one version. And why do we use them? Because, again, this is not the best spelling, or the best grammar, excuse me. So because it needs to be shown in name. Otherwise, you wouldn't know. Is it going to be a +1? Is it going to be a +2? Is it going to be for example, copper 1 and copper 2? If you've got if I say that I have copper chloride and I don't indicate which copper it is, that formula would vary differently, and then therefore whenever you go to react it with other things, you would struggle to figure out what's going on if it's not the right copper. So that's kind of the long-winded version of number 6. It says true or false, true or false, the ending of a nonmetal anion is always changed to "ide." So that itself is false. That is false because there are polyatomic, if you look on your list, it says right there, polyatomic anions. Anion is a negative ion. There are polyatomic ions that have ATE and ITE endings. If I wanted to elaborate more on that, the only time that you have where you're taking a nonmetal anion and you're changing it to "ide" is when you go from sulfur to sulfide, oxygen to oxide, nitrogen to nitride, phosphorus to phosphide, is when you take a atom from the periodic table and it becomes an ion. And then, so you've heard of fluoride. It started out as fluorine before it got in your toothpaste, and now it is fluoride because it's ionically bonded with something else that's in your toothpaste. So that is where we're going for number 7. Number 8, it says true or false, a compound with a polyatomic ion must always contain parentheses with a numerical subscript. Remembering a subscript is that number right down below, like NO3 parenthesis 2. Explain. That is absolutely false. You only need parentheses with polyatomic ions when there is more than one. For example, in math, if you had 3x, that's the example I mentioned to some of you before. If you were multiplying 3x times 1 and you put parentheses around it, do you put a 1 there? No. The only time that you are really ever going to use a parenthesis is if you're doing 3x, put a parenthesis around it, and then put a 2. So, or a 3 or 10 or 194, whatever you're going to multiply that times. So, here, there is only going to be more, if there's more than 1, you need parentheses. So that's where you're going for number 8. So this one, I'm going to show you I feel like it's the easiest route to show you how to do some of this naming here. But number 9, this is what I'm recommending because there's this little space right below the name and right here below the empirical formula. So our job is to write the empirical formula or the name of the compound. If you need it, you're going to use a scratch piece of paper. I'm going to use this little space here. So if you want to draw it out, as we did for number 1 and 3, you may. Some people, on this video, I'm going to show you the short version. So as a reminder, you are not going to be getting the list of common ions that are on the periodic table. That's your responsibility to have that from the periodic table. So to show my work, in order to also help me write this empirical formula, so calcium has a +2, it's in group 2 in the periodic table, it's going to give away 2 electrons. Oxygen, or oxide in this case, is going to receive 2 electrons, so it's going to be -2. It has 6 valence electrons, so in order to get to 8, it needs to have 2, so that would be a -2. So if I was to reduce this down, I could write this as Ca2O2, but that would not be correct because we need our empirical formula, which is its least common multiple. So I divide the whole thing by 2 and end up with CaO. That's the first one. Then we got aluminum phosphide. Aluminum is in group 13, so group 13 means, remember, 13 minus 10. It'll tell you how many valence electrons it has. It's going to be a +3 because we have 3 valence electrons, going to give away 3. Phosphide, on the periodic table, phosphorus is in group 15, so 15 minus 10 is 5, so it has 5 valence electrons. You need to figure out that if you have 5 valence electrons, how many more do you need to get to 8? So we need to get to 3, so we need 3 more, so that would be, again, very similar to calcium oxide is a 2 to 2. We got a 3 to 3. We would not write Al3P3. We would just reduce it down to ALP. Then we've got iron 3 nitride. So iron 3, that 3 will always match the number of the charge it's going to be. And remember, if it's a metal, it's going to be positive, so that's always going to be a +3. And nitride is going to have it's also similar to phosphide. It's in group 15. 15 minus 10 is 5. And then we need to get to that magic 8 number. So again, that is the same as phosphide. So that's a -3. And you might notice that sometimes I do 3 negative and sometimes I -3. I have mentioned before that you can interchange it, however. So again, it's a 1-to-1 ratio. We've just got 1 of those irons. And then that is that. If you were a B-Day person, you might have a slightly different thing here. You might have manganese 4 sulfate. It will work similarly, but for now, for this version, I'm going to continue to use lead 4 sulfate. If you have manganese 4 sulfate on your study guide, please send me an email if you have any further questions after me going through this example. But manganese 4 will actually have the same charge. I decided to put something that would be on your list of those common ions. So lead 4, here we've got a +4. That's going to be, again, intuitive. You just need to be very familiar with your Roman numerals. Sulfate, if you look on the list of your common polyatomic ions, that's going to be a -2. So if I have a -2, if I was to rewrite this, I could, in theory, write Fe2, and then if I have sulfate, it means I have 4. But notice I can also still continue to reduce that down because 2 can go into 4. So then this would actually, we'd end up having 2 divided by 2. We end up with 1 iron, and then we end up with 2 sulfates. So that's what it would look like for lead 4 sulfate. Ammonium, you look on your periodic table, you won't find it. You look on the list of common ions, you will find it. It is a +1. So +1, and here sulfide is in group, sulfur is in group 16. So then it means 16 minus 10, you've got 6 valence electrons. So in order to get 2 to the amount that you need of 8, you need to have 2 more. So then again, this number is going to tell you how many you need of the ammonium. This number is going to tell you how many you need of the sulfide. So if we have a polyatomic ion, which is NH4, and we have 2 of them, we need to have those parentheses. So it would look like NH4 2 and then S. And here we've got copper 2 phosphate, which is what we actually made in the lab with that copper 2 chloride and the sodium phosphate. So we've got a +2. We've got a -3. Please notice that phosphate and phosphide both have the same charge, but phosphate is a polyatomic ion. It is PO4. So if we have a copper 2, and it's going to need to balance it, it has a -3. So that means we're going to need 3 of those coppers, and I'm going to need 2 phosphates. So I need to have those parentheses around that phosphate. So that's where we have that much so far. We're almost done. We've got the name to go for now. Here in this case, if you see one letter, one capital letter, another capital letter, you can pretty much, if you have 2 capital letters and it's a compound, guarantee it's gonna be on your periodic table. So you're gonna find it. It's not gonna be one that's on the list of common ions. So if you look up on the periodic table, you find K, you'll find it's potassium. You look up S and you'll see that it's sulfur. So then you change that to sulfide. If you wrote it like this too, that is absolutely acceptable. So that pH is, or if you also even wrote sulfuride, that would also be acceptable. But sulfide is the correct, both of these are correct. This is the way that you would write it in Britain. So then we got so if you see 3 capital letters, you got 3 capital letters, oh, that'll be your indicator. All right. So those might not necessarily be on the periodic table just by themselves. You do need to use your list of common ions. So we end up having sodium, and then you'll find SO4 on your list of common ions, and you'll see that it's sulfate. Oh, here we go again. We've got 1 capital letter here. We've got 2 more capital letters. So guaranteed we're going to end up with 2 different, obviously cations and anions, but you're going to end up with a polyatomic ion. It's going to be on your list. So you'd end up finding magnesium on the periodic table or just knowing it. And then you have NO3, which is the nitrate. So these 2 right here are going to be a little bit trickier, because here, if you look, you'll see copper. You won't know which copper that is because you have to indicate which copper. You've got copper 1 and you've got copper 2. So the first step you need to do in order to figure out which copper it is going to actually be, if we, looking at the periodic table, you figure out what the charge of your nitrogen is. You find that nitrogen is a -3. Then you have to figure out what's the balance. So if this was copper 2, would that work? So copper 2, and I have 3 of them, then that would be a total overall charge of positive 6. So because I need to make sure that's balanced, that would then let me know if I have 3 of them that would be a +1. So then that would be our copper 1 nitride. Oh, excuse me, I do not know why I put a parenthesis there. Usually the parenthesis does usually go around the Roman numeral, but if you leave the Roman numeral off, it's not the end of the world. All right, and so here, this next one, same idea. So you end up with phosphide here. So we can go ahead and write phosphide if you wanted to start out there. Phosphide has a -3. So if I have a -3 and then our overall charge, so I need to figure out which cobalt this is. Is it cobalt 2 or is it cobalt 3? And so by seeing that I've got a 2 and I've got a 3, and so 2 times -3 is -6. What times 3 is going to be +6. So then that would be a +2. So that would be cobalt. Oh, excuse the capital letter. That'd be cobalt 2 phosphide. And then here we have 1, 2, 3, 4 capital letters. So we are going to have 2 polyatomic ions. You look on the periodic table, you would find NH4, you'd see that it's ammonium. And then you find PO4, and that would be phosphate. That's all for this side. If you are able to kind of get this far on the study guide and have no problems and have a better understanding, you're prepared for the 2.5 on the assessment.